Hello everyone, this is Chandrashekhar welcoming you all to the Daily Dose series for civil and mechanical engineers. In this beautiful series, what we do is we discuss, we share very important concept or sometimes the numerical in a short duration so that your understanding of the subject or the concept become more and more clear. So in today's session, I am going to talk about one of the important concept of fluid mechanics, that is how to identify, how to find out the condition for equilibrium for a submerged body as well as for a floating body. Actually, I am going to talk about the memory tip, how to memorize the condition for a stable equilibrium for a submerged body as well as for a floating body. That is the part of buoyancy and flotation. Alright, those who are here for the very first time, this is my quick introduction. I am mechanical engineering graduate from IIT Delhi, having more than 10 years of teaching experience in GATE, IES and PSUs. So let us start with the concept. As you all know, when a body is immersed in a fluid, there are two forces which are acting in vertical direction. One is buoyant force, another is the weight of the body. And for vertical equilibrium, the magnitude of buoyant force must be equal to weight of the body, isn't it? Then the immersed body will be in vertical equilibrium. That is one condition. So for vertical equilibrium, the condition for equilibrium one is net vertical force must be zero, or we can say the buoyant force exerted must be equal to weight of the body. Other than that, another condition is for rotational equilibrium, we do not want the body to rotate. So for rotational equilibrium, the line of action of buoyant force and weight must be same. Or we can say center of buoyancy B and center of gravity G must lie in the same vertical line. That will give the body rotational equilibrium. Or we can say net moment must be zero, or the line of B and G must be in same vertical line. Once the body fulfills these two conditions, then we further classify the equilibrium to be in three types. The equilibrium can be further classified into three types. One is stable equilibrium, unstable, or neutral equilibrium, based on the reaction of the body to the disturbance. If it slightly disturbs the body, which is in equilibrium, if a restoring force or a couple is developed, if there is a restoring force or a couple is developed which brings the body back to its original equilibrium position, then it is stable equilibrium. Similarly, for unstable equilibrium to take place, whenever we disturb the body slightly, if the overturning force or a overturning couple is developed in the body which moves the body away from its original equilibrium position, then it is unstable type of equilibrium. So the prerequisite for these type of equilibrium is the body must be in equilibrium first of all, satisfying the previous two conditions. Now the third type of equilibrium condition is neutral type of equilibrium. When we slightly disturb the body, if the body attains a new equilibrium position, it means there is neither any force nor any couple developed in the body due to disturbance, then it is said to be in neutral type of equilibrium. Now let us talk about the submerged body. When the body is completely submerged in the fluid and when we disturb the body, then there is a couple developed. It can be restoring, it can be overturning, or it can be no couple to be developed. So based on that, we define the submerged body to be in stable equilibrium whenever B lies above G. So the memory tip or memory trick is BAG. For a completely submerged body, when B is lying, center of buoyancy is lying above center of gravity, then the completely submerged body will be in stable equilibrium. Or you can understand this way. I am holding the body at B, let us say. If B is lying above and G is lying below, then if you disturb the body clockwise, then at G weight will be acting which will bring the body back. weight will develop the restoring couple or restoring moment. If you disturb the body anti-clockwise, then at G, weight is acting in downward direction, which will develop the restoring moment and bringing the body back. If B and G coincide with each other, then if you disturb the body, there is no couple developed. There will be neither restoring nor overturning. So the body will be in neutral equilibrium. If center of buoyancy is lying below center of gravity, I am holding the body at center of buoyancy. At G, weight is acting in downward direction. If you disturb the body clockwise, look, at G, weight is acting in downward direction, which will develop overturning couple. So the body will be in unstable equilibrium. For the submerged body to be in stable equilibrium, BAG must be the thumb rule. Center of buoyancy must always be above center of gravity, and that is the reason in case of submarine, the cabin, or the engine are always kept at the bottom of the submarine, so that G should lie below center of buoyancy. Similarly, in case of hot air balloon, cage is always at the bottom. More is the mass at the bottom, the location of center of gravity will be towards lower part of the body. So B must lie above G for the submerged body to be in stable equilibrium. I hope this is clear. For a floating body, the analysis is a little complicated because there is another point defined other than B and G. There is a point called meta center M. What is meta center? Meta center is the point about which the floating body, when it is in equilibrium and it is slightly disturbed, it is oscillating. The body always oscillate about meta center. So I am holding the body at the meta center. Look, this is the meta center for this given body. Can you see it? This is the meta center. The body is oscillating about the meta center due to disturbance. So look, for a floating body, the memory tip is MAG for the stability. Meta center must lie above center of gravity for a stable equilibrium for a floating body. Like a ship. Ship is an example of floating body. Look, I am holding the body at the meta center now. Earlier, the completely submerged body was rotating about B. So B should lie above G. But here, in case of floating body, the floating body oscillate about meta center. If you disturb the body slightly, at G, weight is acting in downward direction, then weight will develop a restoring moment, which will bring the body back. So it is a stable equilibrium. If M and G coinciding with each other, if M and G coincide with each other for a floating body, then by disturbance, there will be no couple developed. So it will be in neutral type of equilibrium. But if M is lying below G, can you see it here? If M is lying below G, then by disturbance at G, weight will develop the overturning moment. And because of the overturning moment, the body will attain an unstable type of equilibrium. I hope this is clear, and I hope you guys enjoyed the memory tip for a completely submerged body, that is BAG, and memory tip for a floating body, that is MAG. This is all about this session. I will see you in the next session. Till then, enjoy, take care, have a great day. Thank you.